Why do we exist? Is there an ultimate destination that we're chasing? Is there any bigger purpose that we serve through our existence? What is the need for life on Earth when the universe, as we know it, is left empty? If you have pondered similar questions as these for some time, then this video may provide the answers you need. Today, we will discuss some of the theories that try to justify the reasoning for our existence and what scientists have to say about the meaning of life. As always, make sure you're subscribed to our channel and turn on notifications so you'll be the first to access new content. Let's get started. For thousands of years, people have brainstormed reasons to unlock the secret of why the universe exists. Almost every historical culture has come up with its outcome and story, most of them putting the matter in the hands of the gods, and philosophers have written reams on the subject. But science has had little to say about this supreme question. However, in recent years, a handful of physicists and cosmologists have started to push for answers. They claim that we now have a better understanding for the history of the universe and the physical laws that depict how it works. That information, they say, should give us a clue about how and why the cosmos exist. Their admittedly controversial answer is that the whole cosmos, from the fireball of the Big Bang to the star-studded space we now occupy, came into existence from nothing at all. This had to happen, they say, because nothing is innately fragile. This idea may sound bizarre or just another silly creation story, but physicists insist that it follows naturally from science's two most powerful and successful theories, quantum mechanics and general relativity. Here is how everything could have come from nothing at all. First, we must look at the world of quantum mechanics. This is a branch of physics that deals with very small objects, atoms, and the even smaller particles. It's an enormously thriving theory, and it supports most modern electronic gadgets. Quantum mechanics tells us that there is no such thing as space. Even the most perfect vacuum is filled by a churning cloud of particles and antiparticles which glow into existence and almost instantly fade back into emptiness. These so-called virtual particles do not last long enough to be identified directly, but we know they exist by their effects. Our best theory for interpreting such large-scale structures is general relativity, Albert Einstein's crowning achievement, which sets out how space, time, and gravity work. Relativity is quite different from quantum mechanics, and so far, nobody has been able to combine the two seamlessly. However, some theorists have been able to bring the two together on particular problems by using carefully chosen approximations. For instance, this approach was used by Stephen Hawking at the University of Cambridge to describe black holes. One thing they found is when quantum theory is applied to space at the smallest possible scale, space itself becomes unstable. Rather than remaining perfectly smooth and continuous, space and time destabilize, churning and frothing into a foam of space-time bubbles. In other words, little bubbles of space and time can form spontaneously. If space and time are quantized, they can fluctuate, says Lawrence Krauss at Arizona State University in Tempe. So you can build virtual space-times just as you can develop virtual particles. What is more, if these bubbles can form, then you can ensure that they will. In quantum physics, if something is not illegal, it necessarily occurs with some non-zero probability. So it is not just particles and antiparticles that can snap in and out of nothingness. Bubbles of spacetime can do the same. Still, it seems like a big leap from an insignificant space-time bubble to a massive universe that hosts 100 billion galaxies. Surely, even if a bubble formed, it would be doomed to disappear again in the blink of an eye. Most physicists now believe the universe began with the Big Bang. At first, all the matter and energy in the universe were crammed together in one unimaginably small space, and this exploded. This follows from the discovery in the early 20th century that the universe is expanding. If all the galaxies are flying apart, they must once have been close together. Inflation theory proposes that in the immediate aftermath of the Big Bang, the universe expanded much faster than it did later. The most novel answer to Leibniz's great question is to say, our universe exists because it should. The thinking here is that all possible universes have an innate tendency to exist, but that some have a greater tendency to exist than others. The idea is Leibniz's, who entertained the thought that there may be a struggle for existence between possible worlds, with the absolute best one coming out on top as if through a process of virtual natural selection. In the end, he did not accept this idea and retreated instead to a more traditional view that the universe exists because God chose to make it so. But the idea of a virtual struggle among possible universes has appealed to some modern philosophers who have followed it to a reasonable verdict and insisted that the possible universe with the greatest tendency to exist will bring itself into existence. According to this theory, our universe becomes real not because God or anything else made it so, but because it pushed itself out of non-existence and made itself real. Is this strange? Yes, but we should not let that put us off. After all, an outstanding philosophical question might just require a stunning answer that is hard to believe. Well, we're not sure if we'll ever be able to explain our existence, but until then, let's hope that the immense curiosity of humans will get us all the answers we desire someday. And that was today's video, guys. Make sure you let us know in the comments what you think. Also, subscribe to our channel for more intriguing content in the future. Take care.